all happen simultaneously. It's just a string search replace, I think. Oh, ooh, ooh. Alright, hold on, let's tell you what this means. All happens simultaneously. So you can't just do a search replace of this, then this, then this, then this, then this. I think is what it's saying. CN, PC. Because there's a CN. So if you did them one after the other, just in one, like da 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 da, at the end of this pass, like you'd have put the CN to NN from an earlier rule, this NN rule here, and then you get to this CN rule and it would trigger on this CN, and you don't want that. So you just have to make a state machine, basically, that goes from the start of the string and applies all the replacements. So this is you could easily do this if you had a regex, which Jai doesn't really have. If this is Python, this is like dirt simple. You just convert this into a single regex search replace, and you're done. But we are going to do it by 18 a string. It's still simple. It's just not like a one-line thing like it would be Python. Although we could make an index proc for the string library, which I don't think I've done in Anger yet. That might be a way to do it. We look at so we can make a proc which takes a haystack, a needle, a start point, and it. So this is like a wildcard version. And we don't need this part. So we could do, like, we could set up the list of pairs, the rules. Then we could have our proc refer to it. I mean, it's pretty much just, it's kind of pointless, really, since all it is putting a wrapper around the operation we're going to do anyway, so we'd be better just hand coding it. Like we could write this and then call replace with it, and that would do it, but would be just as well building the string once we had the loops. So, what's the first thing? What we did first? I mean, it's gonna grow. Is it gonna grow so much that we need to think of this smarter than we are? Okay. We're gonna do outliers. There. This is this. This is least common, most common. I'm just completely brain dead right now. This is one of these, and this is going to be outliers of common. Okay. Let's parse our shit first. Index 0 else rules is going to be an array of just keep everything as a string to make it simple. polymer string rules. Let's get this. I mean, we don't need 256. We need 27. Oh, we've got we can do for split polymer. We've got table it. Let's count. If it's not equal to 0, well, let's just do if it's equal to 0, continue. It's less than least count. Least count equals least equals index. That's that. We kind of went back to front for some reason. I'm not sure why. So the actual rules were going to be I can't tell. And then we'll do polymer.count minus 2. Pair string slice. Oh, what are we doing? Slice polymer. Let's just substring. if rule.pair is pair, then printer builder or append printer builder. Let's just oh, now hold on. Hold on. We only want to append the first character of the pair. It's the next one all. Don't want this. We just want this. So what we actually want to do is append the first character to the builder. I don't think we need the friend at all. Just do that. So come the end, so that means we'll see the NN, we'll add NC, now we'll see an NC. Is NC a rule? Yeah, so we'll add NB, so we'll have NC, NB, then we'll see CB, CB is H, so we'll add CH, so we'll have this, and then we'll be on a B, the last character, which we just append. It's just fucking, no, it's just slice polymer minus one. Yep. And we're going to allocate every time, but I don't think it matters because every successive string is twice the size of the last one. So even if we read the previous one, it's basically just one step's worth of data. So are we done? We just do polymer for $1 steps, polymer equals process, polymer roots. And then we're going to do percent minus percent equals percent. Most common minus least common. We're going to assert. Oh, we're going to assert it. There's no way that's wrong. Split into 2. Oh, we're returning the do we really care about the actual thing? Don't. We don't actually need the most and least at all. Or maybe we leave them in part 2. Who knows? Look, we got the right answer, you know. It's not the right answer. Hey, oh, this was, wait, was this not the right answer? This was the right answer. How did we screw up? That's 2 days in a row. Not so good. I want to do this on the dummy input. I mean, obviously this must be right because it had the right things. Debugging this is again going to be shit. I guess we do it with the actual output and then visually check it. Seems horrible. How much can it grow? Theoretically, it can only. Alright, it can double, it can almost double in size, which is what it looks like it's doing. This looks like it's more than doubling, which is probably a problem. Because you can only put 1 character in per thing. So it's like it's n plus n minus 1. It's like 2n minus 1 is how long it can be. That's 39. That's 77. It's 2n minus 1. That's too many. No, 77 times 2 would be 140, 154, 153 selected. This would be 306. This would be 611. 619. Let's do that again. 305 times 2 would be 611. But it's found a pair that isn't got a rule for, so it's only 609. Or it's done it twice. And the algorithm was good. Am I making a language mistake? Did I type the right number? 3354. Am I counting it wrong at the end, maybe? Or maybe this is the right string, but we've counted it wrong somehow? Seems unlikely. Can't even do this. So slow. What's in the input? Right, I don't know that. So N B is here. Well, hold on, let's go this way. This doesn't look like the same number. Oh, because there's multiples here. N we've got, B we've got, O we've got, K we've got, H, yep, B, yep, H again, O again, S, yep, B, K, S, S, B, S, B, V, B, C, S. So we've got all of them. But this is minus 999 here? Where's this 999 coming from? Oh, there we go. See, it was easy in the end. It was just dumb people are dumb. Then we waited and we waited and we waited because terminals are really fast. Then we got the actual answer. You do 40 steps. Now, is this going to explode or is it just going to work? Answers on a postcard. Let's get rid of this. Let's get rid of this. Let's get rid of this. Save that. And we're going to save it as part B. And we're going to put the steps to 40 and see if it dies. gonna die, right? So the let's leave this over here and hope it doesn't make my computer explode. So the thing here is this NN. There's no interaction between this pair and this pair, by which I mean like this NN. I wish I could do it like a cool selection here, but basically, if we keep selecting the start of the string here, all this is like the same. Like it, this stems from the NN up here, and it doesn't involve any of the other strings anywhere, any of the tail end of the string. And the same is true for the NC. The NC is here, and then it's here, and then so on and so on. So maybe there's the boundary character, but the internal of it is completely apart from everything else. So we could basically we can recurse down per pair. We can do what's my memory uses at right now. Memory. Looks obviously still using more than the program is. Like, I wonder what step we're on though. So we could do it per pair. We can just make a table of the counts and then add to the table of the counts per pair. So we process NN, then we process NC, then we process CB, and they just recurse for 40 steps. So then in this NCN, we just process NC, then we just process CN. Okay, this doesn't seem to be eating too much memory. I'm gonna stop it. We're gonna print where we are. And we'll compile it so it's not running bytecode. The other thing we could do is, if this is like remotely viable, we could SIMD it. Because time. So let's do. It's gonna double every time, presumably. Do this. New time colon time. Time. And we can just work it out. It seems like it's going to be a chessboard. Yeah, it's doubling every time, right? So 20 doubles, 2 to the 20. It's quite a lot. Well, we're halfway there, so we need to do 20 more. So it's 8 times 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. So it's only 8 million seconds. So we can easily work out that that's 100,000 minutes. It's 2,000 hours. It's only 100 days. That's easily before next advent of code. So we could just leave this running. Okay. Plan B. Hello, Vader people. You just missed me calculating that this would take 100 days to run as it currently stands. So we're going to have to rejig our algorithm a little bit. So instead of building the string, instead of the outline, I think we're actually starting from, actually, this is just going to take the table and work it out from it, and then the stream is not live, just so you know. Stream is 40 minutes in. Alright. Take it easy. Why is that lit up? So our simple solution for part A does not work for part B because it will take 100 days. So we're doing smarter solution. That's right. Which I explained, but I'll explain again. Basically, we're doing this. We've got some rules for pairs, and you insert this character inside the pair that you find in the string. So this is the first gen, second gen. Well, this is 0 gen, first gen, second gen, third gen, fourth gen. So it doubles every time. So we just did this simple string search replace for this. But it works fine for 10 steps, but for 40 it takes 100 days. It could SIMD it and probably get down to 50 days, but it's still going to be like, or even, I mean, hold on, 100 days. If we threaded it, and then we SIMD'd it, does the SIMD even work? Assuming we could perfectly do it on 32 AVX. So that'd be like a 32 times 16 speed up. We could get it down to like a day, like in an optimal universe. Assuming the memory holds out, which probably it wouldn't. No, it wouldn't. Okay, so the smart way of doing it, like the invariance here is, so this NN is like, it's the NCN here, and it's the NBCCN here, but it never interacts with anything beyond the N. And same for, and then so on and so on. So the NC is like the NBC, and then it's the NBC, and so on. And so that's its own thing. So we can just make a recursive algorithm that takes a pair and then generates the string from it, and then does those two pairs by doing the pair again. And we can add the insertions to a table. And where if we curse down 40 times per pair, it'll be faster. No backseat. Yeah, don't tell me shit. If you give me a clue, I will ban you. How do we start doing this? Okay, so we've changed the outliers, so it just takes the table in. We're gonna make, what are these things called? Polymer template. Pair insertions. Oh, yeah, but the goal is 4. Oh, luckily, Lombulian's strat of ruining my games isn't working because Crimpstock is here. Crimpstock will happily let me shoot him for like 4 times. The game won't be stalled forever, waiting for Lone Billion to die. Because we're going to go over here and shoot Crimson. Except, oh, is he gonna ruin everything by running through my line of fire? No. Although is Crimson gonna dodge the shot? It's possible. He is very close to me though. Going to be a ninja. Yeah. Okay. We'll know how that's going to play out. So, this, we're going to have, I don't know what to call it. I guess we just call them. Yeah, I'm kidding, man. I'm kidding. Chill. Element. They call them elements. Okay. This is just being 127 of U8. No, of N because it's a count. The U8 is this part. In fact, we're going to move all this into global just for simplicity. I think we have to add the old chat interference rule. I'm still not sure whether I want to just freeze the chat while they're doing a deathmatch. I kind of like that the chat affects it, but I dislike if you can intentionally mess with it. But oh no, are you hitting me? Woof. I think I'm just ditching like everything. Well, we're keeping this outliers because it's still fun. So do pair. We're going to take a pair, which is string. We call it pair count. So we're trying to int. How is this going to work? We're going to do for. Oh, we can take rules as well. Oh no, because we move rules into global, we don't need the rules to be passed in anymore. We can just use them. So for a rule, it rules if rule dot pair is pair. Oh, we need to know our step. Or rather, I guess we just do it if step 0 return 0. And then here we're going to do I think we don't want this to be a string. We just want to put it on the stack. So we're gonna do pair is just 2 U8s. there. Yeah, this is just the U8. And then when we do this bit, we're gonna do I guess we also want to do actually we could just do and looks fine. So now this is a pair. Left. Can we just do this? I think. And then just getting this not off by one. Or off by anything, it's gonna be fiddly. It's gonna be something like pair count left plus pair count right. Plus one, I think. Otherwise we're gonna return oh no, we need to run on no. This isn't even bad. elements, element. This is one. It would make it very. I fade the text out during a deathmatch because it's way too busy. Also, there's the thing where the text doesn't actually. Most of the time, it doesn't affect the guys because most of the text is the same size, so the text can drop without affecting them. You have to like change that line height, as you know, to affect them. That would You could do that and it would be maybe interesting. It wouldn't change the problem though because you could just like if you type short text then all this space here is empty. So you just type short text to make empty spaces. It would almost make it easier to manipulate them. So here, is it maybe still doing this? But here we're gonna quick count left, quick count right. I'm gonna insert rule dot insertion. And then we're gonna return or break. Just break. Stand on the line. Oh, I see what you mean. Just have like a. But the text lines aren't fixed. Like the length of the height of the header, like the name is different from the height of the text, and the gap between the two things is different as well. And this is going to be step +1, step +1. We're going to change this to process pairs. So I think what we do is we, for split polymer, insert it to get the base polymer counts in, and then let's go back to 10. Oh shit. For got -2. Right, substring. 2. Process pairs, P becomes steps. And then this is elements. How did I screw up? Operator. We need a constant type where we can express your type 2U8. Oh, minors. No, it's just. Oh, because pair isn't a struct, it's a. Ah. That's kind of annoying, but. Are we even checking equality on the process? Okay, so if rule pair 0 equals p0 and rule dot pair 1 equals p1. We can't do this. That's fine. Is that the right first answer? That is the right first answer. Wow, I'm really surprised that came out correct the first try. Because I thought it'd be off by like 1 point of recursion or whatever. VC42. Got it. So does this give me the 40 steps of this one? We go back to this. Put this up to 40. No, is this fast enough is the question. We can go back to finding the timings for it, or the step for it at least. Is there a further trick that makes it? I don't see how you could make it. I guess you could memorize it. Let's do. That's why is that so low? Am I printing the wrong? Hold on. Oh, it must have started at 40, right? It's just doing all the tail bottom bits. Please just go up to last. Oh, there we go. Yeah, 40. Let's get rid of the print. Print. If we see any progress on, if we see another blip here, then it's fine. We can just wait. It's like, how long is this string? 20. So we can wait 20 times. As long as this moves at all, we're fine. But maybe we could, but this memo isn't even going to be. I guess if we memoized with the step, So this is an int from 0 to 40. These are ints that are very small as well. So we don't even need to hash them, we just make an array. They have to be working to return it rather than insert into the table with this. Yeah, this is a bit too long, really, isn't it? So what we need okay. Okay. The memo is just gonna be can we multiply by the no, it doesn't work. So 26. I'm wondering if it would even work. Then we would record the pair and the step it's on total for that, and then when you hit that scenario again, you would just have a value. We need to recurse again. How often is it going to hit that? We're going to hit that quite a lot actually for the lower end. Yeah, okay. So we could use a table with the easy thing, but slow. Or we could, I'm just trying to work out. We've basically 3 U8s, so we just make an array that size. Like a U24. It's 2 to the power 24. How would you need that? 2 to the power 24. 60 million. We could dimension a 16 meg array. That's not that big. That's completely doable. Like, I was thinking of a way to make it smaller, but it was just a dumb, really massive thing. So we're gonna have a memo which will be like step is a U8, left is a U8, right, or rather pair is a pair. And this is a U8, and then we can do hash place blah, and then we put in key, which is a U32. Let's just do this. That gonna fine. Wait, is this? No, it's not. It's int. It doesn't need to be int. It can be. Okay, we'll make it an int. This is too big a number for what I'm doing. Biggest number is going to be 40 in that byte. Computer mode and hex. So we'd have like 30 FFFF. It's like 3 million. So we can probably just do 4 million. And then we need to change this so it returns an int. And then we're gonna return this plus this plus 1. Otherwise, we're just gonna return 1. And this is gonna return 0. But that's not how it works because we have to memorize it. So we're going to do 0, defer memos, memo memory.pair wasn't it? It was p. Memos.key plus equals result. And then first we do if memos actually do this. So we want to do this. We want to, because this needs to be 0. We want to do this and this. If this is greater than 0, return don't need this anymore. I should have checked this was working before I put the memo stuff in, just with the return value, but see how it goes. We don't need this anymore. No, hold on. I forgot. I have to fuck around because the result isn't just an int. The result is a whole bunch of ints. Because we have to pass the table around all the time now. That's the problem. Ah, this is such a pain in the ass. Oh, fuck. It's like... How many letters are there? 2, 3, 4, 5, 6, 7, 7. So it's like 7 ints for every answer. But that thing changes based on the key, which I could hard code. Or it's just like this. It's like one of these every call. But we're only going 40 deep. The table has to store, like, it makes this table 100 times bigger, basically. But we don't need 127. This was like just for the simple thing. Our result is going to be a 1 is going to be what? We'll just say it's 26 ints. Let's make it exists. This is result. It's going to return a result. If result.exists, result. Otherwise, through. Do we need to set this here? I think. But we're passing in the results so far, right? This goes up here. Here we just do result dot values. We've got insertion. This is 1. We call these with the result so far. Oh, we have to mesh 2 results together. Oh, but then we're gonna. Oh, motherfuck. No, this just returns the 0. It goes on with 0. It's not. We don't pass in the current thing. But then do we pass anything ever? No, this is not. So sometimes it seems true. Result exists. It's true. Oh, I already said this is true. Oh, yeah. No, this is part 2. Part 1 was simple. I mean, we're restarting from, like, we're doing it a completely different way because it doesn't. The way we did it for part 1 doesn't scale. It would take 100 days to run for 40 inputs. E.values. this. It's going to be 0, that's fine. So this can actually just be break. No, that's like normal for, we've done that before. When you do it the naive way for the first part, because it lets you, because the data set's so small, and then it amps it up for the second part, and you realize your naive way doesn't work anymore. Is this still running? Jesus. Okay, let's go back, do this down here, put this into down mode, personal mistakes. This is going to be a U8 now. Yeah, how am I doing clears? Here we need to yeah. Do we actually need to pass in? Oh, we do it at the end, can't we? So here, what we do is this, and then do you want to keep this here, and then result versus pairs, totals dot values and plus equals. Result dot values at. Are we doubling up? I don't think we're doubling up. And then at the end, we're gonna add in the top two. Wait, does this make sense? Oh God, my brain is trazzling. Plus equals 1. Index is giant. Is this because it's like a big endy little endy thing? If we move this here, will it be okay? Our index is 67, limit is 26. Okay, where's this one? Oh, of course, we need to make this a bit. This is insertion minus hash car a. That popped super fast. That can't have been right, right? I mean, it's not right because other reasons, but there's no way it processed everything there, did it? What are we calling it with? Oh, because I'm not calculating the results. That was super fast. I'm not. We need to outlier elements doesn't. Wait, why does he not even error? This shouldn't exist anymore. Outliers totals, and then this is gonna be. We don't even need to care about the indexing of it. It should just still work. He says. Let's make this U8. Wait, was it a U8? What was it? Type given result. Totals.values. Okay, yeah. 2 minus 1 equals 1. Don't think we're quite there yet. So this is obviously not firing. Is this? Okay, our key is wrong. Super, super wrong. Oh, because we're placing on and now we're index is 5 million. That's more than when we put this up the top though, right? When we put this up the top, it was like super big. 5 million, totally doable. Let's just add a 0 and make it 1 maybe. 2 minus 1 equals 1, but at least we've got numbers. Have our numbers. Print totals. Okay, these are obviously nonsense. So the outliers thing is working. The thing is, our recursion is not working. What are we doing? So this is true. Alright, do we what time do we do this? Do this down here. Wait, this shouldn't. 1, 2, 3, 4. We're only getting 4 letters, so that's not right. See, it shouldn't. Where's this going? This is 40. This should be 40 lines. That is. So that looks kind of good. Wait, hold on. Where am I printing this? This should be 40. Do we need to clear the memory? Like, shouldn't that should be clear? It should be zeroed. But same thing again. It's just putting zeros in them. Oh, I guess this is the part it does at the end. But it should get to the end, return this to here and here. Then it should add them together. Then it should add 1 to the relevant thing. Hold on, this should be. No, but we've done. It's doing something. 1, 2, 3, 4. But it's only ever. Okay, well let's. We can't really. Well, are we in the easy mode? This is this and this is 10, right? So if we take out this, then we're just running without memorization at all. We get the right answer. So the general idea of it is working. Okay. 1, 2, 3, 4. Why is there only 4? Oh, because we're in the frickin' dummy mode. We're in the easy mode. But then, okay, so the algorithm works, and the memorization works. Wait, why did I think this wasn't working? God damn it. Get rid of this, this. We can leave this print in. Leave the totals in. Okay, if we go up to 40, that doesn't look right. Oh no, it does look. Oh, it's 2192039. I get our 99999 isn't big enough. Okay, this comes up a lot. What is max end? Is it max int? No. Is it int max? This is printf. I think there's it comes up in a how-to somewhere. Go to numbers. Types. You know it'll be like 0 page no. Or we could just, let's look at math. Maybe it's just in math, which doesn't have thing because it's just a module. Here we go. S64 Max. Isn't this what I searched for and I didn't find it anywhere? Damn it. We'd have to import math. Well, I'm up for doing that. What are we at? 2188.189.693529. Seems good. Go back to 10 on this. X on this. 3342. That's what I said. Up to 40. Wow, that was in bytecode. Didn't even have to compile it. Cool. Anyone? Any questions? People follow that? Do we know how we did it? Do you know why it was faster? I mean, we only used 10 megs of RAM to do it. Nobody has questions. Everybody knows what's going on. Christoph's still doing it. Okay, let's go read him then. Okay. Now we didn't need to plot anything. That was sad. Let's delete this. Go, 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 go.